Hello and welcome to the formal charge tutorial. For this tutorial, you should be able to find the number of valence electrons for an atom on the periodic table and also how to calculate the formal charge for each atom in the polyatomic ion or molecule. This tutorial is meant to be a review of formal charge calculation. We will begin this tutorial with a brief review of how to compute the formal charge. The formal charge tells us whether atoms in a Lewis structure have extra electrons or are electron deficient. We calculate formal charge on atoms by taking the number of valence electrons determined from the periodic table and subtracting the number of electrons assigned to that atom in the Lewis structure. This can be from lone pair electrons or electrons in bonds. When we say the number of assigned electrons, we need to consider A, the number of lone pair electrons that are assigned to the atom, and B, the shared electrons that are divided between the bonded atoms. Now let's calculate the formal charge on the atoms in ammonia. The periodic table shows us that nitrogen has 5 valence electrons. From the Lewis dot structure, we can see nitrogen has a lone pair of electrons, both of which are assigned to the nitrogen. The nitrogen also has 3 covalent bonds with hydrogen, and 1 electron from each of those bonds is assigned to nitrogen. Therefore, the formal charge on nitrogen is 5 valence electrons, 2 lone pair electrons, and 3 electrons from covalent bonds. Gives us an overall formal charge of 0. For any hydrogen bonded to another atom, the formal charge is going to be 0 because from the periodic table, we know hydrogen has 1 valence electron. If we use our equation, we have 1 valence electron minus 0 lone pair electrons. And because our hydrogen is bonded to another atom, hydrogen is assigned 1 electron in the bond. We can use this information in our equation to confirm the formal charge of hydrogen by subtracting 1 for the bonding electron. As we can see now, the formal charge of hydrogen is 0. Let's practice with an ion, formate, which is the conjugate base of formic acid. We will begin with the central carbon atom. From our use of the periodic table, we know carbon has 4 valence electrons. This carbon has no lone pair electrons and shares electrons in 4 bonds. Therefore, using our equation, we calculate the formal charge on the carbon atom to be 4 valence electrons minus 0 lone pair electrons minus 4 electrons from bonds equals 0. Oxygen, according to the periodic table, has 6 valence electrons. In this Lewis dot structure, we see oxygen number 1 with 4 electrons from lone pairs and 2 covalent bonds. Therefore, we have 6 valence shell electrons minus 4 lone pair electrons minus 2 electrons from bonds, and therefore the formal charge on the double bonded oxygen is 0. We will next determine the formal charge on the second oxygen atom, which we will call number 2. Again, oxygen has 6 valence electrons. There are 3 sets of lone pair electrons on this oxygen atom, making a total of 6 lone pair electrons. The oxygen has 1 bond and therefore 1 electron from bonds. Using our equation, we can use this information to solve for the formal charge on the second oxygen atom. 6 valence shell electrons minus 6 lone pair electrons minus 1 electron from bonds equals -1. And like ammonia, the hydrogen has a formal charge of 0. Now I think it's time for you to practice computing the formal charge without my help. When you are ready, please pause the video, calculate the formal charge on all of the atoms in the structure shown, and then unpause the video to check your answers with mine. Here is your first molecule to practice. Please pause the video and good luck. Welcome back. We will start by calculating the formal charge on the nitrogen in this structure. We start with 5 valence electrons. There are no lone pair electrons in our nitrogen atom, but there are 4 electrons from the 4 covalent bonds with hydrogen. When we use our equation, we have 5 valence shell electrons minus 0 electrons from lone pairs minus 4 electrons from bonds equals positive 1. And all of the hydrogen atoms have a neutral or 0 formal charge. Now we will have time for you to put those formal charge skills to good use. In a moment, there will be a question on the screen. Please pause the video, complete the question, and then unpause the video to check your answer. And here's the question. Which Lewis structure is better? Both of the following are valid Lewis structures for CO2, but one is better than the other. Calculate the formal charge on the carbon and oxygen atoms in each structure and use this to justify why one structure is better than the other. Please pause the video and good luck. Welcome back. The question has asked us to evaluate the 2 Lewis structures given to determine which of them is better. We will begin by calculating the formal charges on the atoms in the molecule on the left-hand side. Let's start with the oxygen on the left-hand side. We will call it oxygen number 1. Oxygen has 6 valence electrons, and in this diagram it also has 2 sets of lone pair electrons, making a total of 4 lone pair electrons and 2 bonds. This means we have 6 valence electrons minus 4 lone pair electrons minus 2 electrons from bonds is 0. Note the other oxygen atom number 2, also has 4 lone pair electrons and 2 bonds. And so it will also have a formal charge of 0. The next atom is the carbon atom, which has 4 valence electrons. In this diagram, it has no lone pair electrons and 4 bonds. In the calculation for carbon's formal charge, we have 4 valence electrons minus 0 lone pair electrons minus 4 electrons from bonds equals a formal charge of 0. There are no formal charges on any of the atoms in this Lewis structure of carbon dioxide. Let's take a look at the other Lewis structure for carbon dioxide. Let's start with the oxygen on the left-hand side. We will call it oxygen A. Oxygen has 6 valence electrons, and in this diagram, it also has 3 sets of lone pair electrons, making a total of 6 lone pair electrons and 1 bond. This means we have 6 valence electrons minus 6 lone pair electrons minus 1 electron from a bond, giving us an overall charge of -1 on this oxygen atom. Next atom is the carbon atom, which has 4 valence electrons. As in the previous case, there are no lone pair electrons and 4 bonds to this carbon atom. So this carbon also has a formal charge of 0. Finally, the second oxygen, which we will call oxygen B. Again, oxygen has 6 valence electrons, and in the diagram, it also has one set of lone pair electrons, making 2 lone pair electrons, and 3 bonds. This means we have 6 valence electrons minus 2 lone pair electrons minus 3 electrons from bonds to give us an overall formal charge of positive 1. There are formal charges on both of the oxygen atoms in this molecule. The question asked us to evaluate to see which is a better structure. The better Lewis structure will have atoms without formal charges, and therefore the first structure is the better Lewis structure. Thank you so much for taking the time to watch the tutorial. Please feel free to watch the other tutorials, and good luck!